Good evening, class. This is Mr. Rogers. I apologize for not getting this out to you sooner. I wanted to walk through the homework assignment with you and kind of give you some help with this one. Even though it's a tic-tac-toe game, it's quite a bit more complicated, and the assignment says to use the J option pane. I will waive that if you want to use the scanner, because there is quite a bit more going on here to play a complete game of tic-tac-toe. So with that said, I'm going to create and code this for you, and I just want you to follow along with me, and I'm going to try to do this slowly so you can kind of understand the logic. This is tic-tac-toe, and yeah. Okay. And I'm going to there we go. I'm going to create this class, and we're going to call it tic-tac-toe. And everybody's played tic-tac-toe before. This is a very popular game. All right, so as I said, I'm going to walk through this, and we're going to use the scanner class and try to do this in as a straightforward manner as possible. Some of the concepts you're going to see demonstrated in this video include breaking out functionality into different methods for reusability. And I'll kind of talk through that as we go. All right, so we're going to use a public static void main method. And up here, I'm going to go ahead and declare a member variable, char array, bracket. We'll call this our matrix. And this is going to equal a initialization, and we're going to have 3 rows in this. And so what we're going to do is fill this with chars with numbers. So I'm going to do 0, 1, and 2. And then down here we're going to type 3, 4, and 5. Notice that inside the curly brackets I am separating these with commas. All right, and then our last row. The last row is 6, 7, and 8. And this will be the matrix that we use. And basically what we're going to do is, with the scanner class, we're going to take an input, and if they input a 4, we're going to replace the 4 character with an X or with an O. And that's how we're going to do the game. All right, so we have this variable. So let's go ahead and kind of break this out a little bit. Because we're putting our variable as a member variable in the class, we're going to go ahead and initialize the class so that we can use it. So let's, again, I'm waiving the requirement in the assignment to use the object, the J option pane. So you can use scanner, and we'll say new scanner system.in, and scanner use delimiter, and we're going to ask the question, system out print, would you like to play tic-tac-toe with me? And we'll just kind of include the suggestion what they should input, a yes or no. And we're going to grab that input, string yes, no, scanner, next line. And we're going to ask the question, if yes, no equals ignore case y, system out print line. Great. Let's play. Now, for readability down here, I'm going to put just a blank system out print line. That way it gives us an extra line in between these. And we're going to notify the user. You get to be, you get to play with X's, and the computer will be, will use O's. Okay. And if they say something else besides yes, then we'll tell them shucks. Okay. All right. So we kind of set up the basics, but now we need to think about the actual game, how we're going to lay this out. So we have our TTT object, which is the tic-tac-toe, and we're going to have a play method. And let's have the play method accept our scanner. Now, the play method doesn't exist. I'm going to use a little feature here within IntelliJ that allows you to create that method. So I'm going to click create, and we have a private play method now. So now we have a private play method. Well, what are we going to put in that play method? Let's first tell them something about the playboard. System out print line. If I'm playing the game, I'd like to see the playing board. All right. So here's the playing board. And I have a feeling we're going to need to display this quite often. So let's just call display, and we'll create another private method. And in our display, we need to basically iterate through the matrix and display everything. So let's use a for loop. For int I equals 0, I is less than the matrix dot length I plus, and then we're going to do another for loop because this is a two-dimensional array. Say int j equals 0. J is less than matrix, and we're going to pass in the first parameter of I dot length. Now what that gives us, if we're thinking about this matrix that we created up here, I is going to iterate across the rows, right? So I will be 0, and then 1, and then 2. So index 0 is this row, index 1 is this row, and index 2 is this row. So when we say matrix I.length, we're calling each row the length as it iterates across that array. All right. Okay, so let's continue this. J++, and then we need to print out the contents of the array. So we're going to say matrix I and J, and just for visibility, we're going to include an empty space. Okay. All right. At the end of every loop, we want a print line. So we can just simply do that and just put empty quotes inside of it. And at the end of the loop, we also want a print line. This will give us a cleaner display of how things should look. All right, so let's compile what we have so far so we can see what things are going to look like. All right, so it tells us to enter. I'm going to say Y, and that didn't give us at all how we want it to look. I know why, because guess what? Right down here, when we're printing the matrix, we don't want print lines there. We want print lines after each row. Does that make sense? If I do print lines here, when I'm printing across the column, then it won't work right. So let's do that again. So we'll run this again so we can print out our matrix. We say yes, and it prints out our matrix. Okay, so we have done the display. Here's the playing board display. And now we need to think about the process of this game going, right? And this is where a loop is very good. So why don't we do this? Why don't we say while true? And all I'm doing right now is when I say while true, it's just going to keep doing this until I have some type of sentinel value or call break. All right. We really want to make some type of selection. So let's just put a note here and say for x's. And then we'll do another one for o's. This is just our note to ourselves. So let's see. Let's create a method and call it make selection. And for the selection, let's see here. We're going to pass in our scanner. That makes sense. And we're going to pass in an X, a character. And I want this selection to overwrite matrix. And yeah, because I want it to overwrite it when it spits it back out. All right, so let's think about this. Now, we don't have this method, so let's go ahead and create the method make selection. All right, when we're making a selection, we really have two things that we need to be doing here. We need to determine, you know what, let's go ahead and pass in the char matrix for readability here. I'm going to go back up and modify this one. Okay, so we're going to pass that in for readability. But when we're thinking about making a selection on a tic-tac-toe pad, we need to do two things. We need to first find if the particular number in the selection on the matrix is available, and then once we find it, then we need to mark it, right? So let's create a couple of values here. Let's do a Boolean value called selection made, and we're going to set this to false, and I'm going to do another loop, but I'm going to say while selection made is equal to false, and inside of this I want to ask the question from the user, what is the number they want to enter? So I'm going to capture that information with an int, and I'm going to say selection for right now. And we need to know, because I think this value that we have here, let's make this an X or an O. This value could be an X or an O, and so if the selection is an X, then we need to do something different than it is if it's an O. Because if it's an O, we want a random number to be given between 0 and 9, right? Okay, so let's think about this. So we have a random selection. So let's ask the question, if the X or O is an X, right? We can do it like that because a char is really a number, and so we're comparing numbers at this level. We're not comparing strings, okay? Don't get confused there. You can use the double equals with this. So if an X or an O is an X, then let's put a message out to the user. I'm going to take the print line out there for this. And we're going to say, please enter the number of your selection. Now think about that. We're putting this in a while loop because we want it just to keep going, asking this question until if the selection made is false. Now that selection made is dependent upon whether or not we have determined that value exists or if it's already changed. So let's take our scanner. I'm going to say next int, and we're going to assign this to our selection, right? And we're going to say else, and this is where we're going to have selection be assigned by a random number. All right, I'm going to create another method here, and I'm going to call it random number. And that is what is going to populate my selection. All right, so we're going to come back to that in a moment, but that's the method that we're going to use, okay? All right, so let's take a look at this first. Now we need to ask another question. We have a matrix, and don't get too caught up on this random number being read right now. I'm just using it as a placeholder so we can continue our logic, and then we'll come back and create the method for that in a moment, okay? All right, so we need to think about, though, our matrix. Our matrix is nine elements long. It starts at 0 and it goes to 8, and we want to only use we only want to see if the selection will fit between those number categories of 0 and 8. So we need to ask the question, if selection is greater than 8, well, we need to tell the user, system out print line, your number is bigger than our matrix. Try again. All right, this is going to make sense in a second. All right, else we need to find whether or not the value that they've entered is available. We know that a number greater than 8 isn't, but let's say we've on our second trip through this selection, and previously they selected 8, but this time they come through 8 is no longer in the matrix. 8 could be an X, and so when we search for an 8, we need to determine whether it exists or not, right? So let's think about this. Let's create another variable up here, and let's call this a Boolean variable, and we're going to call it the variable founded, and we're going to say it's initialized at first to false. All right. So founded is going to be set by some kind of logic we need to write here. Find selection. So we're going to pass in our matrix. I think that would make sense. And the selection, whatever that number is. Okay. So we know it's going to return a Boolean. It needs to take our matrix and it needs to take this int. All right, so let's go ahead and allow IntelliJ to create the method find selection for us. Okay, so it created it for us, find selection. Awesome. So how are we going to find the selection? This is the question, right? This is the question. So let's think about this. We need to loop through the array and ask the question, does this value exist? All right, so let's do a for loop. Int I equals 0, I is less than matrix dot length. That makes sense. Same kind of logic we used a minute ago. All right, and then we need to have a second for loop. Int j equals 0. J is less than matrix again, but this time we're going to use I, right? And then we're going to say length j plus plus. And now we need to ask the question, because now we're going to be iterating through this matrix, and we're going to be asking, can this value exist? All right, so let's assign matrix element at I and j. All right, so we've assigned that value that's at level I and j. So as it iterates through, it's going to assign that value. And now we're going to ask the question, if item equals our selection. All right, our selection is a number, and the number is not the same as a char number. So there's a couple ways we can do this. The simple way is say string value of selection, and then you could just say char index at 0, and that gives you that value. Okay? All right, so now we're asking the question, if this char equals that char, then it found it. Okay. Yeah. But what if it doesn't find it? Well, we need to alert the user that it didn't find it and that they need to choose again. And so, well, let's think about how we're going to do some control there. Let's put another Boolean variable and say Boolean found is first, it's false. And here we're going to say found is true. And then down here, we're going to return found. That makes sense, but we need to tell the user, right? We need to tell them that they weren't paying attention or something. So we need to say if found is false, meaning we couldn't find the value, we need to tell them, hey, that number is already taken. You need to choose again. Yeah. And I'm going to put an extra system out print line down here to give an extra space for that. All right. If we hit this point and we find it right away, there's no need to continue looping. So we're going to break out of that. All right. So now we've found the selection, right? So we said found it is true. And if found it is true, then we need to mark the selection, right? We need to mark it. So let's put another if statement, and we'll say if found it is true, then let's have it return the matrix again, and we'll say mark the selection. Okay, so what are we going to pass in here? Let's pass in the matrix, and we're going to pass in the selection because we've already validated that it exists, and we're going to pass in our XOR value, right? So XOR at this point, what is XOR? XOR is right here, so we're just going to say XOR right there. Okay, so now this is what we want it to do. We want it to mark our tic-tac-toe board, our matrix, with an X or an O, right? So we have our X and our O. It all depends on what it is when we make our selection, right? All right, so let's go ahead and create the method. And the cool thing about this is much of this logic is already done for us. So I think we can just copy a lot of this right here, and we can paste it in because we don't need to type all that again. But there is some bit of difference here. So we're going to get the char item like we did before, and if the item is there, yep, that's the same, then we need to do something with it. So we're going to say matrix, let's just copy this right here, equals our X or O. Let's change that for readability, keep things similar. Okay, so now we've done it, and we're going to break out of the loop. So we're going to just put a comment here. This will allow us to exit loop early if there is a mark. And then we need to return our matrix that we've modified. Okay, so we returned our matrix. Yeah, it's starting to look pretty good now. It's starting to look pretty good. So let's go back up here to our make selection, right? So make selection is a private char, and it comes down through our logic, and we say that there's a selection to be made. It's false, and so while selection made is false, right? Oh, we found it. So down here we've made a selection. So we need to change selection made and say this is now true. And I'm getting an error message here. What was our... Oh, we're supposed to return the matrix. All right, so we've done all this work, so let's return our matrix. Okay. Now what about this guy? Random number. Well, if he's not an X, then he's going to be an O. And that's where the computer needs to generate a random number. All right, I said we're going to come back to this, so let's do this. Okay, let's do this. Thinking about this random number, I've talked to you some about doing math.random. There's another class that actually generates more pseudo-random numbers than math.random does. And this is called the random class. And it's very easy to use. And math.random only returns doubles. Okay, but random will actually return an int. Ain't that cool? I thought it was. All right. Anyways, we need it to be bounded by 9. And that will give us between 0 and 9, which is appropriate for us. So at this point, we need to come back over here, and we're going to say return. Okay. I missed anything? I think that's good. All right, so the selection was there. And I think it would be good to make a statement in here when we go to mark a selection that you chose to mark such and such selection. So let's do that right here. So, you know, if it's the computer, we might want to put a little bit of logic to tell us that. So if X or O is O, the computer chose position, and we just say the selection. Else you chose position, right? This just makes it a little more user-friendly to whoever might be playing your game. Okay, so we've got a lot of code in here so far. This is quite a bit, but you know, we still have a little bit further to go, and some of this has to do with the rules of the game. And we can lay out a method for that in a minute, but let's go ahead and go back up here now for a moment. Go back to our original play method, and when we make a selection, we're going to start off with the X's, and we're going to say, after we do this, we're going to say display, because we want to display the matrix. And then we want to ask the question, is the game still going? Well, this is a good question to ask. But honestly, how do we ask that question? Right now it's true all the time. Let's put another variable up here and call it Boolean. Let's call it game is going. And we'll say that game is going is true until it's false. So let's see here. If game is going, we need to ask the question. How do we do that? Well, we need to evaluate the game. And we need to evaluate for x's, right? And if game is still going maybe game is going is not the right word. Maybe game is done. It's the right word we need to use here. Yeah, I think so. If game is done, because we want evaluate game to say game is done if it's done. And so if game is done, right, then we need to say system out print line game over. You win. X is rock. Right? All right. And if that's true, then this is where we could break from our while statement. Okay. Well, now we have the same question for our y's, but here's the cool thing. Because we've written this in a way, we can actually just copy all of this, in fact. And you just paste it again, and all you have to change is y, y, and y. No, I'm sorry, not y. We're playing with O's. So we'll change that to O. Guys, I'm doing this video late at night, and I am tired, so forgive me. Okay, so if game is done, game is over, and we want to tell them, sorry, you lose, right? So you lose, O's rock. All right, so this is really the question now. How do we evaluate the game? If the matrix is filled, we want to be able to know that somehow. Well, this is where it gets to probably the most confusing part of what we have to do. We need to create a method that looks at the rules. Okay. So let's do it like this. I'm going to copy this matrix as we see it right here, because we need something as a reference. Okay, and we'll paste that in there, and I'm going to comment this out so it doesn't drive me batty. Okay, we have our matrix, and we know that this is position 0, this is row 1, and this is row 2. Okay, so keep that in mind. And if we're thinking about our matrix in that way, then we need to ask the question based on the rules of tic-tac-toe. So we know what the rules of tic-tac-toe is. If you don't know the rules of tic-tac-toe, then go play a game real quick, because you need to know the rules. All right, but let's write our if statement then. to evaluate those rules. I'm going to put it like this to make it more readable. So if the first row is 0, then this is column 0 as well, right? This is column 1, and this is column 2. So 0, 1, 2, 0, 1, 2, right? All right, so let's bear with me, okay? So we're going to call matrix row 0, column 0. We're going to ask the question, does it equal X or O? And our little value up here got jacked up. There we go. Right? That's a valid question. But we need to ask this in groups of 3. So what we want to say is, does this match, and does matrix 0 column 2, right, which is subscript 1, equal X or O? And, because remember it's always in groups of 3, matrix 0 column 3, which is subscript 3, does it equal X or O? And if that statement is true, if it's true, then we want to return true. Okay? So let's, I don't know why it does that. Let's make these a little easier to read. Keep them lined up. So there it is. And we'll put these over to the side again so we can understand what they are, right? It's always good to use comments. So column 0, 1, and 2. So column 0, column 1, and column 2. That's what that's saying. And if that first row is all X's, then it returns true. So that's one rule. All right. So we need to replicate this rule again and again and again. So we're going to copy this, and I'm going to say else if, and I'm going to line these up a little bit, make it easier for myself. All right, so now we're going to look at row 2, which is subscript 1. Remember, this is subscript, this is row 0, this is row 2, and this is row 3. So 0, 1, 2. So now we're on the second row, which is 1. And we're saying if it equals 0. So this means that this would be 3, 4, and 5. Okay, it's pretty straightforward. Let's copy it again. Okay, we got all of our code jumbled because IntelliJ is trying to format for us. So now we need to go to the third row, which is 2. So we'll change it here. 2, 2, 2. And this would be 6, 7, and 8, right? So 0, 1, and 2, 3, 4, and 5, 6, 7, and 8. And these are our row indices that measure that. So what that's given us is that's given us, if all of these are X's, true. If second row is all X's, then it's true. Or if the third row is X's, it's true, right? Well, as we know, there's other ways that you can win this game. You could win the game if you have a diagonal, right? Yeah. You can win the game if you have a diagonal, or you can win the game if the columns are true. All right, so let's work through this. We're almost done. Don't give up on me yet, okay? We're almost done. So copy this again, paste it in. IntelliJ is gonna jack it up again. And now we need to ask the question of lining up the indices a little bit differently. So we got to do 0, 1, and 2. But we're going to do this one now diagonal, right? Diagonal. So 0, 1, and 2, bam, bam, bam. And we're doing this 0, 1, and 2. So look what happens when we do that. So 0, 1, and 2. So that satisfies the diagonal. And the diagonal in this case would be 0, 4, and 8. All right, I'm going to mark that down so it makes sense. 0, 4, and 8. All right, so that satisfies one diagonal. Let's now do going down. All right, straighten out my code again. So for going down, 0, 1, and 2, we know that these should both be 0 because we're going down. So column row 1, row 2, row 3, and we're only dealing with the first column, right? And what would that be? Let's look at our matrix real quick. Our matrix would be 0, 3, and 6. So 0, 3, and 6. Oops, I did the wrong one. So 0, is it the last one? Yeah, 0, 3, and 6. Okay, so that takes care of the first row going down. All right, let's do the next one. Guys, we're almost there. Please don't give up. I know this is long, but this helps you to think. And you do need to turn this in, so follow along with me and type along with me, okay? All right, so we got 0, 1, and 2. We've got first row down. Let's see here. So then we got second row, or second column, which would be all ones. So the second column in the middle row going down would be 1, 4, and 7. So let's change that. 1, 4, and 7. All right. We're almost there. Almost there. Don't give up. This is the part that gets fun. You can take the game over to your little brother or little sister and have them play it, and they'll get bored with it real quick. All right, so now we're down to the last column. So this would be 2's. Right? And the last column is what? 2, 5, and 8. 2, 5, and 8. Okay. Almost there. Cannot believe we're almost there. All right, now we have only one more to go, and that is the last diagonal. This is it. We just have one diagonal that we have to address. Okay? So we're going to go down diagonally from the top right. So we know that this is correct. This one should be a 1, and this should be a 0 because we're going down diagonally. And in fact, they're opposites of each other, if that helps to think about it. All right, so diagonally, this matrix is 2, 4, and 6. I'm just going to put in the comments so we can always know. 2, 4, and 6. All right. And then if none of these conditions match, then we're returning false. Okay. Let's go back here and look at this. So, based on our code, we evaluate the game. Is the game done? Yes, it's done. And then we break. Otherwise, it gets down here. If we don't hit the break, we go back up and we do while again, because while is always being evaluated to true. And it keeps going through this condition until it's done. All right. I haven't tested the code in quite a while as we've been coding here, so cross our fingers, and if we have to, we'll do some debugging to step through what needs to be fixed. All right, would you like to play tic-tac-toe with me? Let's test the no condition. No. Shucks. Oh, okay. All right, well that worked. So let's go back and do it again. Would you like to play tic-tac-toe with me? Yes. Okay, please enter the number of your selection. I'm going to do 0. Okay, so I chose position 0, X, and the computer chose 6, which is down here. X and O. Okay, so please enter a number of your selection. Alrighty, I'm going to do 1. Uh-oh, look at that. I chose 1, and the computer chose 0. We're both vying for the last one. All right, so I'm going to choose 2. Hit enter. Game over, you win. X is rocks. That's right. X's do rock. All right, guys. That's it. We've went through this assignment. It's very long. It's kind of complicated, but I want you to take your time with this and work through it. Okay? I've walked through the code quite a bit and talked through all the logic. And if you have any questions, please send me a note. Okay, have a great weekend. Stay safe. Don't be going out if you don't have to. You know, I think they said there's a couple more cases in Guam now. And just stay safe, guys. All right? All right.